Okay, where I left off last time, I said I was going to hook the circuit up and take a measurement. Where we were at is we had built the oscillator circuit. We had that built, and then we built the buffer circuit. And so our complete circuit that we've got right now is that right there. That's the complete circuit as it is. So we're going to measure the output over here, see what's coming out of this C7, it's 100 picofarad. And I've got a freak counter in there so that we can see what frequency we got. Now the sampler I've got a little voltage doubler circuit right here, and it's hooked to the positive probe of my voltmeter. The black is hooked to ground, and these are two little 1N 4148 diodes, and they're hooked to where one diode rectifies to the negative and one rectifies to the positive. It's a voltage doubler circuit. The cap is across the two diodes. One's on ground and the positive lead is here. There's a sampler cap. It's a 10 picofarad. The frequency counter's picking up my inverter. I'm off grid here, so this was wondering what's going on because there's no power in the circuit right now. It's a 10 picofarad cap that goes to the plate of the output tube, and then to protect the frequency counter, I don't know what its limits are for input, so I have another 10 picofarad sampling right at that junction, and it's just there just to read frequency. The voltmeter is going to read the voltage developed from the output of the plate from which is pin 5 of the 6AU6, the buffer. So okay, you want to turn that on, let the tubes warm up and see if she'll come to life. Should have about 2 volts. The voltmeter is going to read double whatever that voltage is. So there's already 4 volts. So that means there's about 2 volts there. Heading for 5, so there's at least 2.5 volts of RF. Settling down just a little over 5 volts. Looks like 5.1 volts. And we've got frequency is 3.806 kilohertz. So 3800 kilohertz. Right in the 80 meter band. Okay, we'll get on with what we're going to do tonight. We're going to add some more parts. So give me a second here. I'm going to get everything unsoldered and unhooked so we can move this thing around and then everything's out of the way. Try to do this as quick as possible here. That's the ground and the filament, and there's the V+. Okay, that's out of the way. The voltmeter out of the way. Oop, parts running away here. The frequency counter up. I'll leave a link to this little guy. I forgot to do it in the last couple of videos. It's $16. It's a pretty slick little frequency counter. It runs on 12 volts. Okay. So what we have going to do, get the right paperwork here. This is the circuit we're going to work on tonight. This is V3. This is the resonance detector part of the circuit. It's like a little voltmeter. And we need to add all of these parts. Some of them I've added. When I get to them, I'll tell you what it was that I've done and kind of show you what where they are. I just kind of did that to kind of speed things up, because this is probably the most involved part of the build. And there's our job list. Leave that there for a second. That's what we've got to do. That's quite a load, but we'll start in. So the first one is pin 7 of V3 has to go to ground. Get my solder back up here. And a ground wire. Alright, pin 1 is right here. Pin 7 is opposite that. It looks like there's a handy spot already in there. I don't see. Let me adjust the brightness here. Hopefully that doesn't wash the camera out. Alright. Tin the wire first. Come on, get in there. Okay. Alright, so it's pin 1 to ground. Next, got a C8. It's a C8 is right here, goes to ground from pin 5. C8, it's a 0.01. I'll select a 0.01 from the junk pile here. And we're going from pin 5 to ground. Alright, pin 7, pin 6, pin 5. Okay, that's done. Now, there's another part here. Okay, we got to have a 20K 2 watt. It's R9. R9 20K from pin 5 to the B plus tie point. And let's see, what I have is a 22K. That's close enough. Looking for my big pliers, they ran away from me. Where'd they go? Okay. Gotta clean up this tip just a little bit on the end. Okay, that goes right in that same spot where we just did put that capacitor. Get some solder on it, then I'll move it into its final position. Has to come over here and tie to this wire. So I'll have to just put a piece of wire on it and extend it. Okay, like so. And where's a suitable piece of wire? That looks like that'll do it. And no, try again. I didn't have the other end prepped. Thought it was, but it wasn't. It's like Teflon insulation or something. It's tough. We'll get it. It didn't argue too bad. There we go. Alright, try again. Pick up a little bit of solder on there. Never have enough hands when you're soldering. Okay. Make those just kind of rest together. Alright, that resistor's in. Alright, what next? Okay, we got the 20K 2 watt from pin 5 to the B plus tie point. Can't see it, I got it off camera. So now we got to put a 47K from pin 1 to ground, and that's R7 from pin 1 to ground is a 47K resistor. So let's, got one here somewhere. Pin 1 to ground. Okay. Whoop. Roll of solder falling over. I know, I won't get no solder awards, but that's okay, it gets it put together. Get her done. Okay, get it. Oh, I'm getting ahead of myself here. Show you what I'm doing. Alright. Okay. C9, the 0.01 to ground. From that 47, now we're just right across the 47K. C9, 0.01 from pin 1 to ground. Carried away on my cheat sheets there. Alright, back to what I was doing. Almost got it. Get this solder to melt again. Okay. Alright, that one's in. And next. Okay. C9. So now we go C11 is a 0.01 from pin 2 to ground. C11 from pin 2 to ground, and it's a 0.01. Now, next. Okay, C11 from pin 2 to ground, and we have to run a wire from pin 2 to the plus side of meter M1. That's from pin 2 down to the plus side of the meter. Meter's on the other side. What I'm going to do is put a piece of wire on there, poke it through a little hole that I've got here, and then we'll flip it over and show you the meter. This is going right where I just put that capacitor. I'm going to crimp that because it won't stay there if I don't. This will just make it easier. It's still going to be easy to get undone if I want to use this project for something else. Okay, so now I take and run this over here. I've got a little hole, it's already pre-drilled. I'm going to poke it through there and flip it over, and what it's going to go to is this meter, the positive side. Now, we'll get to it here in a minute, but this meter is protected, and I suggest anytime you have like a 1 milliamp or 2 milliamp meter or a microamp meter, it's a good idea to put some diodes back to back. I'll show how those are in the circuit when I bring the schematic back up here. They're just laid opposite ends. In other words, band in one direction of one diode and the band of the other facing the other direction, and they're just wrapped in parallel and soldered across the meter. What that does, it allows no more than 7/10 of a volt being across the meter. So if something dead shorts in the tube, something goes bad, or your project, those diodes will conduct about 1.5 amps to 2 amps across the meter, and it won't hurt the meter that way. So I'm going to turn it around here where I can get at the back of the meter, and this is the positive leg. On these meters, if you look at the back of them, they'll be marked with a plus and minus, and we're soldering this to the plus mark on the meter. Okay, now I'll show you what I was talking about. These diodes, let me get that where it's in frame. Okay, they're just 1N1004 diodes, and they're just laid end to end opposite, and then like I said, they're in parallel, just soldered together, and you just strap them across the meter. Real simple, but it protects your meter should there be a problem. And let's see, that's where we're at right here. Put the two diodes back to back across meter M1. I just showed you that. Now we've got C12, a 0.01 from pin 6 to ground. C12, 0.01 from pin 6 to ground. Flip her back over here. Okay, pin 7, pin 6 is right next to the where we put that resistor. So let's find another little capacitor that's easy to use. Don't look like it's the right size. 0.01, there we go. it's not going to cooperate. I keep on to slide down, so there we go. Hold it out there for a second. It cools. Alright. Now we can come back and use this ground spot again right there. Okay, that one's in. Now there's a resistor that we have to put there. R8, it's a 10K. R8. Whoop, come on, get in frame. R8, 10K from pin 6. And this one goes all the way to the top end of a potentiometer that's up against, that's mounted on the front panel. So from pin 6 to the clockwise end of R10. That's this little potentiometer right here. That's what the knob, this is a sensitivity adjust. That this adjusts how the voltage or the sensitivity for the meter, for the voltmeter. And this goes to the high end, which is the one over here on the right. So let's find a 10K resistor. Ah, there's one with long leads. That'll work perfect. Tin in the leads here. Okay. Now, gonna snake it down there. Alright, got it. This one's rather easy to get in. Good. Just sit in there like so. All right. What we just put in was this 10K resistor to the top end, and I have a 1 meg potentiometer is a 1 meg in there right now. And so it looks like, let's see, what's next, the center arm or the ground, one or the other. Lower end. So that's the opposite side of the cap, or the resistor rather. The opposite side has to go to ground. So let me find a little piece of bus wire or something here. That looks easy enough. I'll use that. Put a little hook on it so it'll stay right there. All right. If I have enough time, I have a really neat little surprise to show you here. I found something as I was looking around for some schematics and found this right out of an old piece of military equipment. This I think you guys will like. I get time to show it to you here. It's quite a neat little circuit. real simple. Okay, that's in. Now, what's next? Okay, it was this end here to ground. And need a 0.01 C15 is a 0.01 from the center leg of R10 to ground. That's from the center of the potentiometer to ground. And there it is. Close that little loop a little bit. There we go. And we'll just swing that right around over where that last ground wire went. Maybe you're gonna, yeah, I guess the camera will, yeah, it's picking that up, okay. Make sure you can see what I was doing here. This is to keep the any noise from desensitizing the little voltmeter circuit, because if you got the gain up on it, it is pretty sensitive. And what you're wanting is just to read the voltage of the resonance of the coil. So now we're about, I think we're out of our cheat sheet here. Yeah, that's done, but they got a few more things to do. Let me put that up out of the way. Alright, that was this one right here, and that also, see, here's another one of those back-to-back diodes, but one, the negative side is rectifying to ground, or negative. The other rectifier is rectifying to the positive. So here again, this is a voltage doubler. So the voltage developed across this cap will be roughly twice of what the voltage is. That's just to raise the sensitivity of the circuit up. And our sampler is a 10 picofarad cap again. And I think I've got these parts already in over here. I did this just so it would kind of speed up. Okay, this is where, whoop, turn this sideways here. This is a terminal strip. This end is ground, so this has a tab on it that I soldered to the chassis ground. The next terminal is open for us to use, so that's where I tied the diodes and the sampling cap. On this terminal is where our sample comes in, the RF. We have to hook that up yet, but it samples that, and you'll just solder a coil from ground to here. The coil that you're wanting to test just goes from this ground lug to here, and this little cap is going to sample. That's this one right here. The capacitor is unknown or variable, and that's what this is right here. This is so we can vary this to see if it's somewhere within the range of the oscillator or of our frequency that we're using. And it's also a way of finding out what capacitance is needed to make the coil resonate at the frequency that you're going to want. So it's a way of finding out if you need to add turns or take away turns from the coil. If you're having to close the capacitor all the way up to max and you're almost at the right frequency, that tells you that you don't have enough turns on the coil. And on the opposite, if it's wide open and it still won't go high enough, you've got too many turns. Okay, so what we're going to do, this is already on the tube. This was done from the last video. Let's go in and find that, and we'll make sure this is all hooked up. I think it is. Yeah. This green wire, you can point to it right here. That green wire goes under here and it sneaks down under the chassis. That's this wire right here, and it comes up to our 20 picofarad cap that's right here. It's on pin 5, I believe. Yeah, from pin 5. But I grab it to show you what we're talking about. This cap is right here. It says 100 on this one. This circuit is for if you're going to use it for a VFO. This is, I didn't need that much capacitance. I just wanted a real light sample, so I went down to 20 picofarad. But if you were going to use this for a VFO, the same circuit, you would put 100 puffs, so you'd have a little more power coming out of from your tube. But that's C7, goes to pin 5 of V2. All right. So now I'll break this right here, and I'll come back in the next video. I'll have the power supply hooked up. We'll hook a coil in there and show you how that works.